Go to the folder where you downloaded the flange geometry, and it's a WBPZ file, and double click on it to bring it up in ANSYS. And double click on the geometry cell to take a look at the geometry. And it says starting design modeler being the geometry application that comes up. And let's take a look at the model along Y. So click on Y here. And if I zoom in using the middle mouse button, zoom in once more, rotate the model using the middle mouse button, you can see the four parts. Zoom in a little bit more. I can see this a little bit better if I turn off the transparent view. So I'll go to View and turn off frozen body transparency, so that doesn't show them as transparent anymore. And I can see my four parts, and if I go here to the tree and expand this, 3 of the parts are suppressed and we are left with 4. So we have the mid nozzle, the lower nozzle, the bolt, and the nut. Mid nozzle, lower nozzle, bolt, and the nut over here. There is a boundary value problem defined by 3D elasticity valid over each of these parts, 4 parts. So we have 4 boundary value problems, and the 4 boundary value problems are coupled at the interfaces between the parts. And if I go up the tree here, I see there's a symmetry object. This is what is used to cut the model as per periodic symmetry. And you see the symmetry planes are plane 8 and plane 7. And if I look at plane 8, I see it's offset from plane 7 by this angle, which is essentially 180 degrees minus this value, so 0.9 degrees. What we have is a 0.9 degree slice through the full model to get the reduced model, which contains half a bolt, whereas the full model contains 200 bolts. And we can take a look at the full model by suppressing symmetry. We'll do that, but I will do that, in a copy of this geometry, because I don't want to corrupt this geometry in any way, since we'll be using it for the analysis.